the lecture series of optical instrumentation. This is lecture number 8, and in previous lecture we started lasers. So far we have discussed about stimulated emission and absorption phenomena, and in previous lecture we discussed Einstein relations. In this lecture we shall discuss about pumping, population inversion and classification of lasers. Okay. So, the topics are pumping, population inversion, lasers, classification of lasers, and then few type of lasers, solid lasers. Now, what is pumping? Now, we know that to perform lasing action, we need to perform the phenomena of stimulated emission, and for stimulated emission, we need more number of atoms in excited state. So, how can we get more number of atoms in excited state? By exciting the electrons, by exciting the atoms, by supplying more energy. So, supplying energy to the laser material is called pumping, and there are various pumping methods. For laser action, the pumping mechanism maintains a higher population of atoms in the upper energy level. As I told you, we need to achieve a state that is called population inversion, that we shall discuss. Okay. So, by pumping, the state of population inversion is achieved and it is maintained. Fine. A higher population of atoms in the upper energy level relative to that in the lower level. Okay. Active system is a system in which population inversion is achieved. Pumping is the method of raising the particles or electrons from a lower energy state to a higher energy state. And there are various pumping methods. The most commonly used pumping methods are optical pumping. Optical pumping is one of the most common. It is mainly used in solid state lasers and in semiconductor lasers. In solid state lasers, or we can also call them doped insulator lasers. Electrical discharge, this is mainly used in gas lasers, or we can supply energy using chemical method or thermal energy we can also supply to excite more electrons from ground state to higher state. Injection current and atom to atom collision, in elastic atom to atom collision. So, these are the methods of supplying energy to the material, so that we can get more number of atoms in excited state or E2 state to perform stimulated emission and to get laser light. Okay. So, next is population inversion. It is a state in which the number of electrons in excited state are more than the number of electrons in ground state, that is invert of the normal condition, that is why it is called population inversion. Okay. So, here you can see a graph, a normal distribution of electrons in a 2 energy level system. So, this is energy level E1, this is energy level E2, and the distribution of electrons is given by Boltzmann statistics that we saw in previous class while discussing Einstein relations. So, it is G1 exponential E1 by kT minus N by kT. So, over here you can see this is the graph for normal, this is the curve for normal distribution of electrons in when the material is in normal state. So, you can see this is the energy on y axis, there is energy. So, over here is the energy of E1 energy state that we are calling ground state, and this is the energy of E2 energy state, excited state for this 2 energy level system. So, there are 2 energy levels E1 and E2. On x axis there are number of electrons. So, the number of electrons we can see are more in even energy state. How many electrons are there? N1. and number of electrons in E2 energy state are very less in comparison to even energy state. How many? N2. Okay. N2. So, N1 in even energy state and N2 in E2 energy state. So, this is normal condition when we have not supplied any energy. The number of electrons in ground state are far more than the number of electrons in excited state, and as the energy increases, number of electrons decreases exponentially. Okay. So, this is normal distribution. So, when we supply energy using any pumping method, we achieve population inversion, and this is the condition for population inversion. This is normal distribution. Now, we have supplied so much energy that almost all the electrons, not all, but more number of electrons from even energy state are excited and they have reached E2 energy state, and we have to maintain this condition by supplying more and more energy by pumping. So, when the number of electrons in excited state becomes more than the number of electrons in ground state, then this condition is called population inversion. And to get laser, to achieve lasing action efficiently, we have to achieve this condition. So, we have to supply more energy. Now, you can see in this state the number of electrons in ground state N1 have become very less, and the number of electrons in excited state, that is N2, have become more. Why? Because we have supplied energy H nu, and the more number of electrons have jumped in excited state from ground state to excited state. Okay. So, A in thermal equilibrium, B after population inversion has been achieved. Now, this is population inversion for 2 energy level system. So, this is for 2 energy level system. This is less efficient. This is less efficient, and we if we use 3 energy level system, it will give us more efficiency. So, this is a normal distribution for 3 energy level system. Now, you can see there is one ground state, we are calling it E0, then E1 state and E2 state. Okay. So, in 3 energy level system, we supply energy and electrons get excited from E0 state to E2 state, like this. Pumping, through pumping we have excited electrons from ground state to E2 state. Now, in this 3 energy level system, this E1 state is metastable state, metastable state. Now, we know in metastable state electrons can stay for a longer period. So, for 10 to the power minus 8 seconds, electrons will stay in E2 state and they will jump in E1 state. Over here they can stay for longer time, maybe 10 to the power minus 5 seconds or 10 to the power minus 3 seconds. So, what will happen? These electrons absorb energy, jump to this state and rapidly come to this state. Now, due to more waiting time, over here the number of electrons will become more, and so we have achieved population inversion in even state, and this is jumping from E2 to E1 is non-radiative. This is called rapid decay and non-radiative. Okay. Now, when electrons from this level to this level, they jump from E1 to E0, we get a photon and we get a lasing photon of energy E1 minus E0, and from 1 photon we get 2, from 2 we get 4 and 8, like stimulated emission we have already discussed in our previous class, previous video. Okay. What are the benefits of this 3-level system over the 2-level system? In 2-level system, the number of electrons in N1 state became very less. Okay. These are very less electrons. So, what will happen? We keep on supplying energy, but there are no electrons in ground state to absorb that energy. So, the efficiency is less. Also, there was no metastable state. We need a metastable state so that electrons can stay there for a longer period, so that we can achieve population inversion more easily. Okay. Over here there is a metastable state, the electrons will stay for a longer period, okay, and so it is easier to achieve population inversion. But again energy is getting wasted because there are less number of electrons in ground state. What we need? We need more electrons in ground state and we need more electrons in metastable state. If we get more electrons in metastable state, we can achieve population inversion easily, and if we have more electrons in ground state, then we can supply energy and easily by absorbing we can maintain more electrons in higher states also. Okay. So, 4 energy level system can be used. In 4 energy level system, as you can see, E0, E1, E2 and E3, when we supply energy, what will happen? The electrons from ground state jumps to E3 state. Now, with rapid decay they come to E2 state. This is non-radiative decay. This is again a matter stable state, and electrons will stay for longer period. Okay. So, we have achieved population inversion between these two levels. When electron from E2 state jumps to E1 state, we get laser photon lasing action, okay, and through rapid decay electron will jump from E1 state to ground state rapidly, again non-radiative transition. So, due to this rapid decay there are more number of electrons in ground state to absorb energy, and there are more number of electrons in metastable state, so that we can get laser that is of higher intensity. Okay. More number of photons, in lasing photons we are getting due to this metastable state, and there are 4 energy, this is 4 energy level system. Obviously, there are more number of electrons in this material. So, this is how to achieve population inversion in 2 energy level, 3 energy level and 4 energy level system. 4 energy level system is better than 2 and 3 energy level system. Next, classification of lasers. So, lasers are broadly classified according to the state of their active materials. Okay. So, solid state lasers, in solid state lasers active material is in solid state, gaseous lasers and liquid dye lasers. Semiconductor laser, in semiconductor lasers active material is also in solid state. Okay. They can be discussed with solid state lasers or separately also, because mainly in this heading we are discussing doped insulator lasers. These 3 are doped insulator lasers. Okay. Ruby laser, Nd-YAG laser, Nd-glass laser, all these 3 are solid state laser. That is why I have kept semiconductor lasers separately. These are gaseous lasers, helium neon laser, argon laser, CO2 laser, carbon dioxide laser. So, the active material is in gaseous state, and in liquid lasers we shall discuss liquid dye laser. Okay. So, solid state lasers, in which active material is in solid state. It is generally an insulator doped with some impurity that provides energy levels for laser transitions. So, we need energy levels for laser transition. We have seen 2, 3 and 4 energy level system, okay, and how lasing action is performed in 2, 3 and 4 energy level system, that we have also seen. So, basically the active material, there is a insulator, there is a crystal of a insulator, and a active material is added as impurity inside that insulator crystal, okay, and that active material provides states for lasing action. So, we have to discuss these 3 lasers: ruby laser, Nd-YAG laser and Nd glass laser. Okay. So, ruby laser, it is one of the initial lasers that was developed and was extensively used in various applications. So, what is ruby? Ruby is a artificially grown crystal of aluminum oxide. Okay. It is a synthetically grown crystal of aluminum oxide, and a impurity of chromium, a doping of chromium is done, and what is the percentage of doping? 0.05%. So, 0.05% impurity of chromium is added into the crystal of aluminum oxide, and it is called ruby, and that is why the name ruby laser. So, what is the active material? Active material is chromium ion. So, the energy level of chromium ion takes part in the lasing action, okay, and aluminum oxide acts as a stable material, it provides stability. This is the construction. So, this is, you can see, this is a cylindrical ruby crystal, and it is kept inside a cavity completely silvered mirror. So, this is the cavity, and inside surfaces of this cavity are completely silvered. So, it is a mirror. Inside this mirror there is a cylindrical crystal of ruby, and over here optical pumping is used. You can see there is a flash lamp as a helical, and when we give power, it will glow, and through optical photons the chromium ions will get excited, and we achieve population inversion, and through stimulated and spontaneous emission we get laser over here. Okay. So, this mirror is partially silvered, not completely silvered. So, some part will go out, some will be reflected again inside, and this is switch control. And again there is a cooling system, because if we keep on supplying energy, pumping, so there is obviously some amount of energy will be emitted in form of heat. Okay. So, due to this cavity, the photons keep on reflecting, and again we get more photons for stimulated emission, we get more photons, and ultimately due to this cavity we get huge amplification and directionality. Okay. Now, this is energy level diagram of ruby laser. It is a 3 energy level system. So, optical pumping around wavelength of 5500 angstrom photons are used, and this we have already seen in 3 energy level system. Electrons get excited from ground state to E3 energy state, and through radiation less rapid decay they come to metastable state. This is E2 state, that is metastable state, and from E2 electrons jump to ground state, and we get laser of 6943 angstrom wavelength. Okay. So, we get photons of this particular wavelength. So, the ruby crystal is slightly pink and reddish color. The color depends upon the amount of impurity that is added, that is the amount of chromium that is added inside it. Next is Nd-YAG laser, neodymium yttrium aluminium garnet laser. So, Nd, neodymium, and YAG, yttrium aluminium garnet. So, the active medium, what is the active medium? It is made up of two things, yttrium aluminium garnet Y3Al5O12 and with the doping of neodymium, rare earth metal ion neodymium. So, neodymium is acting as active material, okay, and yttrium aluminium garnet is acting as base compound. So, again this is also doped insulator lasers and they are also optically pumped using flash tube or laser diodes. So, this laser operates in both pulsed mode and continuous mode. Ruby lasers are normally used in pulsed mode. Okay. So, this is the construction. You can see there is a cavity, cylindrical cavity. Inside this, this is the rod of active material, that is neodymium Nd-YAG material, and this is flash tube. It will emit photons, and this, the inside surface of this cylinder is highly silvered. So, this is a kind of mirror. So, all the photons that are emitted, they get reflected and strike this laser rod, and we get population inversion, and through stimulated emission and spontaneous emission we get photons of particular wavelength and we get a laser light. And this is mirror, this mirror is 100% reflective. So, no optical output will, no light will come this side, and this is partially reflecting mirror, partially silvered. So, partial, some light will be reflected back and some light will be transmitted. So, we get laser from this end, okay, and this is power supply. This is energy level diagram. So, this is 4 energy level system. You can see E1, E2, E3 and E4 is made up of combination of energy levels, group of energy levels. So, neodymium will be excited through pumping the electrons of neodymium atom, and through fast radiative decay they are coming to E3 energy state. From E3 through E2 we get lasing photons, and through again rapid decay they go to ground state. So, this is 4 energy level system that we have already seen. Okay. So, it is 4 energy level system. So, that is why it is more efficient than ruby laser. Neodymium ions provide energy levels for both lasing transitions and pumping. Okay. These lasers have many different applications in medical and scientific field, such as LASIK operation, surgery and laser spectroscopy. Fine. Next is Nd glass laser. Now, the working of Nd glass laser is almost similar to Nd-YAG laser. The only thing is the base material, the host material is different. In place of yttrium aluminium garnet, glass is used in this laser. That is why the name Nd glass laser. So, glass provides an excellent host material for neodymium. Okay. So, that is why these days Nd glass laser is used more. Nd glass lasers are operated in pulsed mode and the output spectral line width is greater than Nd-YAG laser. So, output spectral line width is more than Nd-YAG laser, but it is only operated in pulsed mode. Okay. So, if we Nd-YAG laser we can operate in pulsed or continuous mode. So, if we need any, if I have any application in which we need a laser of continuous mode, then we cannot use it. In pulsed mode we can use Nd glass laser. Also, glass can be doped heavily. We can add more impurity to glass than yttrium aluminium garnet. Okay. So, if we add more impurity, then we have more atoms of neodymium. If we have more atoms of neodymium, we get more electrons, we get more photons of correct energy, and the intensity for same amount of material, for same amount of pumping, the intensity, the efficiency of ND glass will be more, up to 3 times as much energy. Okay. So, that is why we can get up to 3 times and as much energy as compared to Nd-YAG laser, can therefore be produced by Nd glass laser. Okay. Working construction are similar, almost similar to Nd-YAG laser. Why? Because active material is neodymium. So, energy level diagram will remain same for Nd-YAG laser and Nd glass laser. Okay. And construction also optical pumping is used. So, construction will also remain same, almost same. So, this was all about doped insulator laser. In next lecture, we shall discuss about semiconductor lasers. Okay. Thank you.